Hey, good morning, everybody. This is Mr. Aynesworth again, and we're going to get into part one of how to graph translated sine and cosine waves or functions. Okay, the goal is to identify the amplitude, the period, the phase shift, or simply the shift of the wave axis, which is also called the midline. So some of you guys might have been from a teacher who called it the midline. So wave axis, midline, same thing. Given the graph, and write two possible functions of the form. This needs to be modified. I got a little typo right here. Okay, so here we go. Let me rewrite it here. Of the form y is equal to a times the sine of b times x minus h, okay, plus k. And the other one, if we add k to both sides, I'm going to rewrite this one here too. Y is equal to a times the cosine of b times x minus h. All right, plus k. So we're going to be dealing with that form there. Okay, there's two ways you can write it, and I just wrote it the second most common way. Okay, so let's define our functions first. Our terms here, like the period, the amplitude, shift, and all that. Okay, so first definition here, the period is just the distance between two successive maximums or minimums. Okay, so P stands for period, as you guys know. That's nothing new here, and it represents your distance here. Distance. Okay, so it's the distance between, two successive maximums, okay, or minimums. And obviously I'm going to do this. Oops, got to spell that right. I'm going to do this with you guys, and it will make all sense here in a momento. Okay, so it's the distance between two successive maximums or minimums. The amplitude, you're gonna find out that it's the maximum minus the minimum. All right, and average that. So maximum, not average, but divide that by 2. Okay, it's the distance above the wave axis. So key here, and I'll illustrate this when we get started here. It's the distance above, the wave axis. Now, I keep saying wave axis, but after talking to a few people here, I found out that a lot of teachers use the word midline. So wave axis, same as midline, the line that goes through the middle of the wave. Okay, your shift is how it's translation. So it's a translation here. So your shift or translation, same word here, is h comma k. All right, it tells you basically how far do you go left or right, whether it's negative or positive, and then how far do you go up or down, whether it's positive or negative. Okay, so it's a horizontal shift and then a vertical shift. So h is your horizontal shift and k is your vertical shift. And your wave axis, the way you find that, okay, just WA for short, your wave axis here is your average of the max and mins. So it's the average of the max and mins, and the way you find an average, you add them up. So it's the max plus the min, and then you got to take half of that because you got to divide it by 2 because you're taking an average here. And this always happens to be, okay, the k value in your translation. So it's equivalent to y equals k, as we're going to see. All right, so let's just go ahead and define that just initially here, and let's just go ahead and apply it. So here we go. We've got a graph here of a function. All right, and our goal is to write the graph in two ways, in terms of sine and in terms of cosine. Okay, it says write two possible functions, for the given graph. Okay, so let's do that. Okay, so here we go. So what we're going to do is we're going to take a look at two maximums. All right, so here's a max, and over here's a max. And what we want to do is take a look at the distance between the maximums. Okay, so take a look at that. So you go down here and you go, okay, this is at 3, and go down here, and this is at 11. All right, and I want to look at here the distance between 3 and 11, and there's your period. Okay, so 11 minus 3, well, that's usually 8. So my period is 8 units long. Okay, so sometimes you don't have pi involved, believe it or not. It all depends on what they what b is here in the function. Okay, so I know right off the bat, just as I just talked about, the period is 8. Okay, now the amplitude. Okay, so the amplitude, all right, is the distance between the wave axis and the maximum. So it sounds like we need to graph the wave axis. Okay, so let's grab a red pen and let's see here. So let me see, the max is at 5, it looks like. Okay, 5 high. The minimum is at -1 high. You got to go between there. You got to find the distance between those two. That would be this right here. That'd be just the distance. It's not the amplitude or anything like that. We got to try to get the wave axis here. And the wave axis is the max plus the min divided by 2. So in this case, the wave axis, WA for wave axis, all right, you got to take 5 and add it to -1 and divide that by 2. So here we go. So y is equal to 5 plus -1. So 5 plus -1, divide that by 2. So y is equal to 4 divided by 2, or 2. So if we draw the wave axis through 2, which is right here, by the way, we should be able to divide the wave into 2 equal halves. So here's your wave axis going right through the wave. Okay, so that's called y is equal to 2. That's my wave axis. Y is equal to 2. And then what's the amplitude? Well, the amplitude is the distance above the wave axis. So here, let's represent the amplitude here. So if the wave axis is at 2 and that max is at 5, then the distance from 2 to 5 is 3. So the amplitude is 3. So the amplitude is now known. You could also take max minus min divided by 2. Let me just illustrate that. So 5 minus a -1, divide that by 2, and that'd give you, hang on, gotta redo that. 5 minus a -1 is 6, and 6 divided by 2 is 3. So again, max minus min divided by 2 will also give you the amplitude. Okay, it's the distance above the wave axis or the midline. So now we know the period, we know the amplitude, now we got to find the shifts. And I'm going to leave this blank because the shift for sine is different than the shift for cosine. So I will write down the shifts here down below. All right, so now let's take a look at what we have here. We want to write 2 possible functions, right? One in terms of sine and one in terms of cosine. And I've said this before, but you probably don't know this until this example here, that every sine wave can be represented as a cosine wave and vice versa. All you have to do is shift it. That's all you have to do. Okay, so let's talk about sine first. So the sine function typically starts at the origin, as you guys know. So I'm going to make a note of that here. So I'm going to switch to a new color here. And okay, so I'm going to make a little note in purple here. So the sine function starts at the origin. So sine starts typically at the origin. Okay, you guys know that, untranslated, okay? Now, obviously, this has been translated. It's been shifted left, right, up, and down. So the question is like, where does this sine function, where can you shift a sine function to get this sine function? So we already know that the period is 8 and the amplitude is 3. So what we need to do is, let's note this. Let's go in the margin and note that, okay? So we know the amplitude is 3, all right? Because of that, excuse me, we know that not the amplitude. Oh yeah, the amplitude is 3. We know that the period is 8. So we also know that the period is equal to 2 pi divided by b in general. And if the period is 8, that means, all right, if you do your arithmetic here, that means that b is equal to, if you switch b and p and do a little solving right here, that it's 2 pi divided by the period. So in this case, it's 2 pi divided by 8. So the coefficient b has got to be pi fourths. Okay, so now I know b. So I know what the period or the amplitude is 3. I know b. So my function that's not translated yet can be written as a times the sine of b x. Okay, I already know that from the previous lesson. So my untranslated function looks like 3 times the sine of pi force x. This is if it's not translated, okay? Not translated, okay? Now, but this has been translated because it doesn't start at the origin, right? So the question is how can you get to this function? So remember what I'm going to go off to the side now. Remember what sine usually does. So the parent function for a sine of x, if you're just going to graph it right really quick here, it starts here, it goes up and then down and then back up again. All right, where this is 2 pi. If for a typical parent function, y equals sine x. It starts at the origin. Notice this. It starts at the origin, all right, and it has an up and then a down. Okay, so it goes up and then back hits the axis and then it goes down. So it has this up-down cycle. Well, we need to figure out where does this have an up-down cycle. So we have a couple possibilities. We have an up-down cycle here. Don't know exactly where it is. And I also have one here. I'm going to call it point A. So I'm going to zoom in on that. So the question is like, how do you get from the origin to point A? Well, the answer is simple. You translate it right 1 unit and you go up 2 units. So right 1 up 2, and there's your shift. Okay, so I'm going to bring that down here. So my shift for this one here is 1 comma 2. So 1 comma 2, and that's h comma k. All right, where h is 1 and k is 2. So my first possibility here for this one is y is equal to 3, because a is 3, times the sine of x. Excuse me, I got a b here, sorry. Okay, so b is pi force. So let me write that in. So I got pi force times x, all right, minus h, but h is 1. So minus 1 here. And then plus your k value, because you got to go up 2, so plus 2. And there you go. There's the possible function in terms of sine. Now, the same function can be written in terms of cosine, but cosine's different. Now, as you guys know, going back to your parent functions, so again, this always comes back from what you know. A cosine function, cosine x, starts at 1, and then it goes down, and then back up, and then back up to another maximum for a period of 2 pi. So cosine starts at a max, and then goes to another max. So we have to understand that. So for cosine, a normal cosine function that has an amplitude of not 1 but 3, because this function has an amplitude of 3, would start at 3. So I'm going to note that here. So cosine starts at 3. Cosine starts, okay, at 3. Oops. At 3, because it has an amplitude of 3. That's where the maximum is if it's not translated. But as I keep saying here, this has been translated. So the question is how do you get from the amplitude right here on the y-axis at 3 to this maximum? And the answer is you got to go right, all right, and you got to go up. So the question is you got to go right 3, just count 1, 2, 3, and then you got to go from 3 to 5, so it's up 2. So my shift, and let's write that down over here, for cosine is, right 3 comma 2, and again this is h comma k. So my cosine function is y is equal to 3 times the cosine of pi force times x minus the h value, which is 3 right here, and then plus k, which is 2. So yeah, there's quite a bit involved here. And that, my friends, is how you handle a shift, okay? Given a graph, you could write it in terms of 2 different functions, and all you have to do is just figure out the proper shift to do that. And by the way, this is not the only 2 shifts that you can use. If you're thinking about another shift, there's, believe it or not, there's an infinite number of shifts possible to represent it either in terms of sine and cosine. All right, and that takes practice, it takes experience. Like, for example, on the sine function, going back to the sine function, I went right 1 up 2, but I could have picked this other one here at point B, if you look closely at point B, and I could have shifted right 9 and up 2. So 9 comma 2 could have been your shift for sine. This is a sine shift. And I could have written the same function in terms of that shift too, which would give me the same graph. And you can verify everything with Desmos here. And you should make a note of that. You could type the functions in, take a look at it, and you can see what I'm talking about, which you should do. So I'd probably do this in class with you guys, just to prove the fact that, I'm not saying anything bogus. All right? So give it a shot. There are 2 more examples right through here, examples 2 and 3. And you should try them because one example is never enough. And after you try your examples here, examples 2 and 3, check the instructor's notes. All right, and then you'll get an idea if you're right or not. And if not, well, you better come and see me in class or before school, and I will help you out. Okay. All right. So this is just one example of how to shift sine and cosine, or given a graph, how to write it in terms of sine and cosine. Because again, every sine graph can be written as a cosine graph and back and forth. And I should have said function right there. Every sine function can be written as in terms of cosine, and every cosine can be written in terms of sine. You just got to get practice. All right, this is Aynesworth. I'll see you in my next lesson. See you then. Bye-bye.